Let's continue our discussion now. Okay.
Okay, sir.
VPN. So we complete our discussion on side-to-side VPN, side-to-side
Yes.
VPN with crypto map. Remember?
Yes, sir. Yes.
Crypto map. Wait. So today we are trying to focus on GRE implementation, MGRE, and DM VPN. Wait. So now the point is, if you remember our side-to-side VPN implementation with crypto map, for example, we have two sites, site A and site B. We are connecting these two sites over this public network, over this untrusted network. This portion we are using as a public site portion, public site network. If you remember our crypto map configuration, so in crypto map, we can first generate our session key, then we can create
Yes.
our phase one tunnel, right?
Yes,
Then
sir. Yes.
then phase two tunnel. For phase two tunnel, we can create transform set. Let me open the text file. Wait. So if you remember this configuration step, first you can generate your session key. After that, you can create your phase one tunnel and then transform set. And we can create our interesting traffic, right? Which interesting traffic I want to allow through VPN tunnel. We can
Yes.
define in ACL. In ACL.
Yes.
So the problem with the problem with the crypto map is you need to create ACL entry. You need to create ACL entry. For example, in our previous lab, we have only one loop back this side. For example, 1.1.1.1, trying to communicate with this 3.3.3.3. So we can create
Yes.
ACL entry. ACL
Yes.
entry we can create on site A branch office. In site A branch office, source IP is 1.1.1.1 and destination IP is 3.3.3, right?
Yes, sir.
You can create ACL entry on site B branch office, and here we have this source IP address and this destination IP. So this is single IP. This is single IP. Let's take example. Let's take example in your LAN site portion, in your branch site portion, you have multiple networks, for example, or multiple
Yes.
computers, for example, and you
Yes.
want to allow these source and destination through your VPN tunnel. For example, you have 100 networks this side, 100 network this side.
Mm.
So we can create an entry for these LAN portion. We can create an entry in ACL. In ACL, we can define source IP, destination IP, source IP, destination IP, source IP, destination IP. I need to create a lots of ACL entry, right? On site A branch office. Clear my point? I need to create a lots of ACL entry inside a branch office. Same, I need to configure ACL entry inside B branch office, and inside B, I can define source IP and destination IP. Interesting traffic. If this particular source is trying to communicate with particular destination, yes, traffic is allowed. If this source is trying to communicate with this particular destination, yes, we can allow through ACL. Akbar, clear my point?
Yes, sir. It's clear.
The issue is what into this design. I need to create a lots of ACL entry. If I'm working in a big scenario, so it's not possible. Okay, it's very difficult to create. It's very difficult to create a lots of ACL entry. That's why what we are doing, that's why we are using GRE option. That's why we can go with GRE, generic routing and encapsulation. So we can create GRE tunnel here. I'm facing some issue in crypto map implementation. That's why I'm going with GRE. In GRE, what you can do? In GRE, you can create a virtual tunnel from site A to site B, a virtual tunnel. This is called GRE tunnel. I'm not talking about IPsec, okay? I'm not talking about IPsec. This is not IPsec. GRE is a separate tunnel, Akbar. With GRE, you can create a tunnel in between site A and site B branch office. And to create GRE tunnel, you require two things: source public IP and destination public IP. So to create GRE tunnel, you need source public IP and destination public IP. And what is GRE tunnel? You feel like it's a logical cable, okay? You have a direct cable from this branch office to this branch office. It's like you are connected directly with site B branch office. And when you create this tunnel, you can define IP address. For example, here I'm creating tunnel one. So I can provide IP address 192, for example, any IP you can provide. It's your private tunnel, so you can provide any IP address. For example, 10.1, and here I'm creating tunnel 2. IP address 192.168.10.2. My point is, we can create tunnel here. So logically, you feel like you have a direct cable from site A to site B, just like your directly connected router. So now you can use any dynamic routing protocol. You can use any routing method to create reachability, from A branch office to site B branch office. If you remember our crypto map lab, Akbar, so we don't have
Yes, sir.
reachability from LAN to LAN, right? In crypto
Yes.
map lab, we don't have any reachability from LAN to LAN. No, in crypto map scenario, we have a reachability only in between source public IP to destination public IP. But here, what we can do, we can create a tunnel behalf of this source public IP and this destination public IP. We can create our tunnel, and this tunnel is not secure. This is just a GRE tunnel to create a reachability from site A LAN network to site B LAN network. This is just for reachability. You can create a routing protocol, any routing protocol, to create a reachability. And once you have a reachability, after that you can implement IPsec. So our focus is on how to create a GRE tunnel in between site A and site B. This is our task. Clear my point, Akbar?
Yes, sir.
Let's create a topology, for example, then you can get a clear picture. For example, I have site A branch office, site R3 I'm using as a site B branch office. So into this design, R2 is acting as a service provider, as a ISP router. R2 we are using as a ISP router. This is site A branch office, site A. This is what? Site B branch office. In between R1, R2, I'm using 10.1.12.0 network. This side, I'm using 10.1.23.0 network. And for LAN traffic, yes, I'm creating some loop back. So 1.1.1.1 slash 32, 10.1/24. So we are creating two loop back on R1 and on R3. So 3.3.3.3 slash 32 and 30.1/24. So let's do the basic configuration first. Basic configuration is what? I'm trying to prepare site A branch office, site B branch office, and just like a real scenario, I will configure default route towards ISP. default route towards ISP. Why? Because I want to create a reachability from this source public IP to this destination public IP. Remember, I told you for VPN implementation, we need two information, source public IP and destination public IP. Let's move on R1 so we can configure interfaces, fast Ethernet 0/0, 10.1.12.1, mask, no shutdown, loopback interface 1.1.1.1/24, loopback 192.168, 10.1/24, show IP interface brief. Now from R1, this is site A branch office. So from R1 towards ISP, I'm configuring default routing. So for any unknown destination, ISP is my gateway. Let's go to R2. R2 we are using as a ISP. So host name is ISP. Fast Ethernet 0/0 12.2. 23 dot show IP interface brief. Let's go to R3 router. R3 0/1 interface 10.1.23.23.2 mask no shut now. We can create loopback interface 3.3.3 mask. So from R3 from site B branch office, I'm creating default route towards ISP. Okay, let's define host name first. This is site B branch office, site B IP route for any unknown destination. 10.1.23.1 is the next hop IP. And this is site A branch office. So host name is site A. So now you can verify your basic connectivity. What I'm doing, I'm trying to verify my basic connectivity. I'm trying to verify my connectivity from this source public IP to this destination public IP. So 10.1.23.23.2. And I have a reachability. I have a reachability. Akbar, can you hear me?
Yes, sir, I'm hearing you.
I have a reachability, okay? You can see now from this site A branch office, from this site A branch office, I can communicate with this site B branch office public facing interface IP, but I don't have any reachability in between LAN portion. So 3.3.3.3 with source 1.1.1. So I'm not getting reply. See, I'm not getting reply. So we don't have reachability. Now let's try to create our GRE tunnel. I'm not looking for crypto map. For IPsec VPN, I'm not looking for crypto map. Why? Because in crypto map, the issue is what? ACL entry. If I
Yes, sir.
have multiple networks, if I have multiple computers, I want to allow these source and destination through VPN tunnel, then yes, I need to create interesting traffic. So I'm not looking for crypto map. I'm looking for next implementation. This is called GRE. So let's create our GRE tunnel. Let's create our GRE tunnel. So how to create GRE tunnel? It's a simple task. Interface tunnel is a command. Interface tunnel is a command. Question mark. You can see you have a big number. You have a big number to create your tunnel. So I'm giving any number here, just like an interface, any interface number. So I'm using interface tunnel one. Now IP address. So this is your private tunnel. This is your private tunnel. So you can give any IP address. any IP address. For example, I'm using 192.168.80 dot network. 80 dot network. So 80.1 I will configure on site A branch office. So IP address 192.168.80.1 mask. And this tunnel, to create this GRE tunnel, you require two information. You need two information: source public IP and destination public IP. So into this tunnel, I can define tunnel source. Tunnel source. So tunnel source is what? Here,
10 dot.
here we are using 10.1.will.1, and
Yes.
here we are using 10.1.23.2. So now tunnel source is 10.1.will.1 and tunnel destination is 23 dot. Done. Done.
Okay.
This is your GRE tunnel. Okay. You can verify now. Show IP
Tunnel disconnect.
interface tunnel brief. So you can see this is your tunnel. Let's go to site B branch office. Site B branch office. How to create GRE tunnel? It's a simple command. Interface tunnel, tunnel number. You can select any number here. No problem. Now tunnel source is 10.1.23.2. Tunnel destination is 10.1.12.1. And what is IP address? 192.168.80.2 I'm using here. So this is our private tunnel, okay? Private tunnel. It means you have a direct cable. Logically, you have a direct cable from this interface to this interface. Logically, you have a direct cable. So for example, you have two router, R1 and R2, for example. You have a direct cable like this. So you can configure any routing protocol. You can configure any routing protocol here. So what I'm doing, I'm trying to advertise, I'm trying to advertise these networks in EIGRP protocol for basic reachability. But before this, you need to verify your connectivity with your tunnel IP. So I'm here inside a branch office, and I'm trying to verify my reachability with 80.2. Let's verify 192.168.80.2. And I'm getting reply. I have a connectivity with my tunnel interface IP. I can ping 80.2. Now you can use any routing protocol, router, AIGRP, 10, network. So in protocol, you can advertise your tunnel IP, and your LAN network. So 1.1.1.1 wildcard mask 192.168.10.0 wildcard mask no auto summary. Let's go to site B branch office. We can use any routing protocol to create reachability here. So in protocol, we can advertise tunnel IP 192.168.80.0 wildcard mask 3.3.3 wildcard mask network 192.168.30 dot network wildcard mask no auto summary. Akbar, you can
Yes, sir. Yes,
verify
yes.
now. You can verify now. You have a route. You have a route. Okay, here we are here inside a branch office. You can verify now. You have a route from R3. Let's verify. See, you are receiving route. So you have a reachability, right? You have a reachability.
Yes,
If I'm trying to capture the packet in between site A and site B, let's verify what information is traveling through this tunnel, through this uh, GRE tunnel. Okay, let's go to here. Let's go to site A branch office first. So my point is what? Here we have a reachability. Here we have routes. This is site A branch office, and I'm receiving all the routes from site B. And I can verify my connectivity. I can ping 3.3.3 with source 1.1.1. Yes, I have reachability. I can ping 192.168.30.1 with source 1.1.1.1. I have a complete reachability. But the point is what? This is GRE tunnel, but the point is this GRE tunnel is not encrypted. Akbar. This is
Yes,
your
sir. Yes.
GRE tunnel, but this GRE tunnel is not encrypted. You can see if any attacker is trying to capture traffic information, signal information, then attacker can verify what's going on, what information is traveling. See, in Wireshark, we can verify yes, traffic is traveling in between this source public IP and this destination public IP. And yes, GRE protocol is running here, generic routing and encapsulation. And what is data payload? This is data payload. Data payload. See, this is source IP, destination IP, source IP, destination IP, and this is your protocol. You
Yes, I
are
see.
trying to verify your connectivity. This is data payload. So
Yes, sir.
attacker
Yes.
can verify what's going on, what information is traveling in between site A and site B. So we can
Yes.
create our GRE tunnel for reachability, but GRE tunnel is not secure. GRE tunnel is not secure. That's why we can go with GRE plus IPsec. Okay. So now we can secure our tunnel with IPsec. We can secure our tunnel with IPsec. Now we can go with IPsec site-to-site VPN implementation. So if you remember our IPsec configuration, we can generate session key, we can create phase one tunnel, then transform set. Remember, Akbar?
Yes, sir. Yes.
So
Yes, sir.
let's
Yes.
let's go here. Let's create our session key. Command syntax. If you remember, crypto, Isaac EMP key. I'm using CCNP 123 address, and this session key I want to exchange with other branch office public facing interface IP. This is 10.1.23.2. So I can generate session key. Once you generate your session key, then you can create your phase one tunnel. So crypto Isaac EMP policy.
Sir, sir,
Yes,
one doubt, one doubt.
yes,
The key you mentioning here now, it is the pre-shared key, right?
yes. The pre-shared key is a method, Akbar.
Okay, yes.
This is
For
session.
authentication.
This is session key. For
For
example, for authentication, I'm using pre-share.
yes,
If I'm using
authentication. We can
method
use
pre-share, it means I'm using same key on both branch office. Pre-share
okay,
is a method, and this is your pre-shared key.
okay.
This is called
Then why we
session
use
key. This is
diffusal
called
method?
session key.
So
This is called
then
session key.
session key.
Yes. And
Then we
pre-shared,
use
pre-shared is just a method.
uh,
It's just a method. You are saying I'm using same session key,
okay,
same key on both branch office. This is your key, and this is a method.
okay, sir.
Pre-shared is a method only.
Okay,
Pre-share means what? I'm using same session key on both branch office. Authentication pre-share. Then for hashing MD5, for encryption triple dash, for Diffie-Hellman group 2. This is your phase one tunnel. What about phase two? Transform set. Remember crypto
yes,
IPC
yes.
form
For
set.
data transfer.
So transform set. This is for yes, phase two tunnel. For phase two tunnel. So transform set, we can give a name for transform set. I'm using TS and ESP triple dash, ESP MD5 for hashing. Done. So this time I'm not creating any ACL entry. If you remember our crypto map implementation, in crypto map, we need to create interesting traffic, right, Akbar?
Yes, sir. Yes.
But I
That's on the
don't want to
interface.
create, but I don't want to create a lots of ACL entries. That's why I'm looking for this new implementation. Next implementation is a GRE.
Yes.
So I'm not creating any interesting traffic. What we can do here, we can create profile. We can create crypto IPsec profile. We are not creating crypto map here. Whenever you are doing a lab with GRE, we are not creating crypto map. We can create a profile. If you remember our previous lab, so we can create crypto map, and this crypto map we can apply on public facing interface, right, Akbar?
Yes, sir. Yes.
But here we can create profile. Whenever you are doing a lab with GRE, MGRE, or DMVPN, you can create IPsec profile, not crypto map. So profile name, you can give any name for this profile, prof1. Into this profile, you can call your transform set. So set transform set is what? What transform set name we are using? TS. So we can just apply transform set. And this profile, you can apply on tunnel interface. If you remember our previous lab, we can create crypto map and we can apply crypto map on public facing interface, right? But in GRE scenario, we can create IPsec profile. In profile we can apply on tunnel interface. So what is tunnel interface number? Interface tunnel. What is tunnel interface number? Tunnel 1, right? Remember our tunnel interface? Our tunnel interface number is tunnel 1. Akbar. Clear? Any confusion?
No, 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 sir. So far clear. So far clear.
So now, how to apply our profile on tunnel interface? What is command? So tunnel protection, IPsec profile. And what is profile name? Prof1. When you
Yes.
press enter, when you press enter, you are getting a message Isaac MP is on.
On. Yes. Yes. It is on.
Isaac MP is on, and now you're not receiving any packet here because there is a tunnel configuration on site A branch office. Let's try to configure on, see, neighbor relationship is down. Yeah. Let's go to site B branch office, and I'm creating phase one.
Okay.
So crypto Isaac MP key is CCNP 123 address 10.1.12.1. Now crypto Isaac MP policy 1 authentication precious encryption triple dash hashing MD5 and Diffie-Hellman group. Now crypto IPsec transform set, and transform set is TS ESP triple dash ESP MD5. So you can create your session key, you can configure your phase one tunnel, then transform set. Now let's create our profile. So crypto IPsec profile. What is profile name? You can give any name here. So prof1. And now here we can apply set transform set. And transform set is what? TS. This profile we can apply on tunnel interface. So our tunnel interface number is tunnel 1. Interface tunnel 1. How to apply? Tunnel protection IPsec profile. And what is profile name? Prof1. Done. Isaac AMP is on, and you can see now you have a neighbor relationship. You have a neighbor relationship with Site A branch office. This is 80.1. This IP we are using on Site A. So you can see now you show crypto Isaac AMP Shah. Let's verify our phase one tunnel information. This command, this command we are using to verify our phase one tunnel. So yes, we have a phase one tunnel. This is old one, it's deleted. Now this is your actual tunnel. In between this source public IP, this is your source and destination. Let me check our configuration is 23.2. Yes. Let's go to here. Show crypto Isaac MP Shah. So yes, we have a tunnel in between this source public IP to this destination public IP. Let's verify again here. Yes, we have a proper source is 23.2. No, I think there's some mistake. Wait. 23.2. Here we have 12.1. Okay, it's okay. So now we have a tunnel between site A and site B. Now tunnel in between site B and site A. And if you are initiating any traffic, for example, I'm trying to ping 3.3.3.3 with source 1.1.1.1. Okay, before initiate this traffic, let's go to here, Wireshark, and I'm trying to initiate some traffic. When you press enter, you can see now you have some ESP information, right?
Yes,
You
yes.
have some ESP information and encapsulating security payload. And now you can double click, you can see only in packet header, you can see only your source public IP and destination public IP information. That's it. And ESP protocol. REST information like source and destination IP, LAN IP. I'm talking about LAN IP. This information is not available here. Okay, you can see our actual traffic is what? We are trying to communicate with 3.3.3 with source 1.1.1 and traffic is what? ICMP traffic. ICMP traffic. This information is not available. This information is what? Encrypted. Akbar, clear for you?
Yes, sir, it's clear.
Attacker can only get source public IP and destination public IP and ESP. That's it. After ESP, everything is encrypted. So this is what our GRE. This is what our GRE implementation. No need to
Yes,
create ACL entry. But here we have a problem. Again, here we have a problem in GRE. If you have a problem in crypto map implementation, then we have a problem in GRE implementation. GRE we are using only for point-to-point connectivity. If you have only two branch office, then yes, you can go with GRE. No problem. Site A and site B, you can go with the GRE. Now let's take example. If you have multiple branch office, multiple sites, for example. Okay, you have one more site, R4. You have one more site, R5, R6. So if I'm looking for GRE tunnel first, GRE tunnel. So remember our GRE tunnel configuration. Let me show you again. GRE tunnel configuration, show run interface tunnel one. So you can verify your tunnel information. This is the command syntax to create a GRE tunnel, right? Interface tunnel,
yes, sir.
then tunnel source, tunnel destination, tunnel IP. So you can use these commands to create your GRE tunnel. For example, if I'm trying to create tunnel in between site A to site B, yes, this information is correct. If I'm trying to create a tunnel in between site A to site C, for example, C, D, and E, then I can create a tunnel in new tunnel. In new tunnel, I can define source public IP and destination public IP. Then in case if I want to create a tunnel in between site A to site D, yes, I can type interface tunnel 4 tunnel, and in tunnel, I can define tunnel source public IP and tunnel destination public IP. My point is if you have 50 branch office or 50 sites, 50 site for example, and you want to create VPN tunnel or GRE tunnel, for example, GRE tunnel. So you need to create
50
50,
profile.
50 tunnel here in site A branch office.
Yes, sir.
And I'm talking about only site A branch office.
Yes, yes.
50 tunnel on 50 tunnel. If you have 50 sites, you need to create 50. And in each tunnel, you can define source public IP, destination public IP. The next tunnel, source public IP, destination public IP.
Yes, sir.
Okay. Now, in case if you want to create a reachability in between this site B branch office with all sites, then again 50 tunnel you need to create. It's a very difficult task, right?
Yes, of course.
That's why we can go with next implementation. This is called what? MGRE. MGRE, multi-point GRE. multi-point GRE. In multi-point GRE, yes. See, if you remember our GRE discussion, in GRE discussion, yes, we can create a lots of tunnel in between sites. And in each tunnel, you need to define your tunnel source public IP, tunnel destination public IP every time. So I don't
Yes.
want to do this. That's why I'm looking for next implementation. This is called MGRE,
Yes.
multi-point GRE. In multi-point GRE, what you can do? You can create a single tunnel. You can create a single tunnel. For example, you have multiple branch office, for example, C, branch office, for example, D. Okay, here I'm using 10 dot. Here I'm using 10 dot 1 dot 34 32 dot 2. Here 10 dot 1 dot 45 dot 2. So now in MGRE, I can create a single tunnel, but in a single tunnel, I can map all the branch office. I'm not creating 50 tunnel. No, I will create a single tunnel in MGRE, but into the single tunnel, I can map all the sites, source public IP, destination public IP, source public IP, destination public IP, source public IP, destination public IP. So in MGRE, I'm not creating 50 tunnel. I will create a single tunnel, and into the single tunnel, we can map all our sites. Clear my point, Akbar?
Yes. Yes, sir. Yes.
So let's go with this implementation MGRE. Wait, I need to power off these routers and let's add one more router into this design.
Sir, if you want any restriction in this scenario, so we have to depend on access list again, right?
Yes, and see, I don't want to create access list. That's why I'm looking for GRE, MGRE,
No,
and
no.
D.
I'm asking you restriction, like I want to block any portion of the network like
Then
this.
then you
So
can
we
then
have
you can
to,
decide ACL.
ah,
Then
yes,
you can
that's
decide
it.
ACL. But this ACL is not, it's not part of your VPN implementation.
Okay.
This is just for to allow or block your traffic. You have a
Okay.
reachability. You have a reachability. Now you can decide. If you want to block
Okay, sir.
anything, you can configure ACL. No problem.
Okay, okay, sir.
Now let's wait. I need to add one more interface here. Okay, let's do the basic configuration first. Okay, Akbar, please wait 5 minutes.
Configuration gone once you power off, right?
Yes, Akbar?
Configuration removed once you power off, right?
Yes.
Yes, yes. Okay, that's it. Okay.
This is a new implementation. That's why I'm doing the
Okay,
basic configuration again.
okay, okay.
Okay, Akbar, can you hear me? Let's verify our connectivity here.
Yes, I'm hearing.
10 dot, 1 dot, 23 dot, public to public IP connectivity first. So we have reachability. Yes, we have reachability. I'm trying to verify my connectivity with 24.2, public to public IP reachability first. Because if you have reachability, then you can create your tunnel. So now I'm trying to create MGRE tunnel. Okay, let's go with the text file. Now this text file can help. Akbar,
Yes, sir.
file can help you to implement your MGRE.
Yes.
Let's go to the R1. So let's try to understand our command syntax first. Then we can go with the configuration. So first you can use interface tunnel command. Interface tunnel command. In our design, we are using tunnel IP 80, right? So 80.1 I'm configuring on site A branch office. Then tunnel source, either you can define your exit interface or you can define IP address. So tunnel source IP is 10.1.12.1, right?
Yes.
But tunnel destination, we have multiple sites. We have multiple branch offices, multiple sites. And we are not using GRE, we are using MGRE because I don't want to create 50 tunnel. Okay, I will create a single tunnel. Into the single tunnel, I will do all my mapping. So here, tunnel source, you can define tunnel source, and then you can define tunnel mode GRE multi-point. So you can specify with this command, I'm using GRE multi-point. Then you can use IP NHRP. This is called Next Hop Resolution Protocol, NHRP. So here for mapping, we are using NHRP protocol. With IP NHRP command, you can define your network ID. It's just like a router ID in OSPF. In OSPF, we have router ID concept, right? Behalf of router ID, router can exchange information. Akbar,
Should be different in different branches, right?
you can use any number, no problem.
Okay,
Let me complete this first, okay? But my point is what? This is just like a router ID, okay?
okay, sir.
So here we can say network ID concept. In network ID, you can select any number here, any number here. For example, here I'm using 177. I will show you what number you can select, and you can select any number. It's just like a router ID. For example, you have two router, R1 and R2. If I'm using OSPF protocol here, so each router has a different router ID, right? I cannot use same router ID on both the routers in OSPF. Akbar. Here we
Yes,
have
sir. Yes, sir.
network ID concept. So I cannot use same network ID on each sites. No. For example, here I'm using 177. On other branch office, I can select any other number. And after that, you can go for your mapping. After that, you can go for your mapping. So let's start our configuration with site A. Site A. So command syntax interface tunnel 1. Now tunnel IP. So yes, 192.168.80.1 mask. Now what is tunnel source? So 10.1.12.1. Yes, this is tunnel source IP 12.1. Now what was tunnel destination? So we can define tunnel mode GRE multi-point. We are not using GRH here. We are using GRE multi-point. So IP NHRP network ID, and you can see you have a big number. You have a big number. For example, I'm using 5, Akbar. On other sites, I can use 6, 7, 8, 9. I cannot use same network ID on each branch office, just like a router ID.
Mm. Yes, sir. Yes.
Now IP, NHRP, and now we can do all our mapping into this single tunnel. I am not creating multiple tunnel. No. Into the single tunnel, I can go with mapping. So I'm trying to map with site B. So what is site B? Tunnel IP 192. Okay, IP NHRP map. What is tunnel IP? 192.168.80.2. And what is public IP on site B? 10.1.23. This is your first mapping. Now for site C, IP NHRP map. IP NHRP map. And tunnel IP for site C, 80.3 I will configure. And what is public IP? 10.1.24. Clear my point?
Yes, sir.
Done. Let's go to site B branch office. Site B branch office. This is R3. Yes. Site B branch office. So on site B branch office, interface, tunnel 1. Tunnel IP 192.168. Yes. 80.2. Mask. Tunnel source. Yes. 10.1.23. This is tunnel source IP 23. Tunnel mode GRE multi-point. IP NHRP network ID. I'm using, for example, 6. Now IP NHRP map. So I'm here. I'm inside B branch office. I'm trying to map this site B branch office with site A and with site C. So site A is what? Site A tunnel IP is what? 80.1. And what is public IP? 10.1.12.1. Now IP NHRP map I'm trying to map site C, 192.168.80.3. And what is public IP? 24.2. Done. Let's go to site C. This is your site C. So interface tunnel 2, for example, IP address 192.168.80.3 mask. Now tunnel source, yes, 10.1.24. Now tunnel mode GRE multi-point. Now IP NHRP network ID, you can select any number here. So I'm using 7, for example. Now this is site C branch office, Akbar. This is site C branch office, and I'm trying to create a mapping for site A and site B. IP NHRP map 192.168.80.1. This is site A public IP, tunnel IP. And what is public IP? 10.1.12. Then IP NHRP map. IP NHRP map 192.168.80.2. This is site B branch office tunnel IP. Now 10.1.23.2. This is what? Public IP. Done. So we have mapping with site A and site C. If I'm trying to verify my connectivity, let's verify our connectivity from this site A. Show interface IP brief. So yes, I have a tunnel. If I'm trying to verify my connectivity with all tunnel interface IP, let's verify our connectivity with 80.2. I have a reachability. With 80.3, I have a reachability. Akbar. So I have a reachability with tunnel IP. If I have a reachability, then I can use any routing protocol. Akbar, clear my point?
Yes. Now we can use any routing protocol to redistribute routing.
So now we can use any routing protocol for connectivity. Router AIGRP 10. And into this protocol, I can advertise tunnel IP and LAN IP 1.1.1, network 192.168.10.0 wildcard mask. No auto summary. Let's go to site C, for example. Router AIGRP 10, 192.168.80.0 wildcard mask. 4.4.4.4 wildcard mask 40.0 wildcard mask. No auto summary. Let's go to site B branch office. So protocol, yes, router AIGRP 10, 192.168.80.0 wildcard mask. Network 3.3.3 wildcard mask. 30.0 wildcard mask. No auto summary. Now let's verify our neighbor relationship. Show IP EIGRP neighbor. Please wait, it's taking time. So you can advertise your protocol. You can advertise your network's tunnel IP, LAN IP in protocol. Let's go to site B branch office. So yes, we have tunnel IP, LAN network. Let's go to R4. So we have tunnel IP and LAN portion. You can also verify your tunnel information again. Show IP. Interface brief 80.1, 80.3, and on R3 show IP interface brief 80 dot. Okay, let's verify. Show IP AIGRP neighbor. So please wait, it's taking time. Akbar. Okay, wait.
Yes,
Let's
sir.
shut down this
Yes.
interface. Sometime you can face this issue. So you can just shut down your physical interface and use a no shutdown command. No shutdown command. Let's go to this interface, shutdown and no shutdown command. This is 0/1. Yes, 0/1. Let's check R2. So on R2, 12.2 is it correct? 23.1 and 24. But clear this command syntax. This will take time, but just clear this command syntax.
Yes, sir. Yes, I got it.
This is our MGRE implementation. Okay. Once you have a reachability, then yes, you can go with IPsec implementation.
Okay.
Phase 1, phase 2. This is our topic, GRE and MGRE. Akbar, clear now?
Yes, sir. Yes, sir. Now, can you just verify that the routes are available or not in the router one?
Yes, I'm waiting. Okay, I'm waiting. I'm not getting neighbor relationship.
Yes, yes. I will.
So you can face this issue sometime. Okay, you can just delete your routers or you can add a new one. No problem.
Okay, okay, okay. I think
But my
because we are
point
running
is,
on
but my point is,
virtual environment.
but my point is, uh, this is command syntax for MGRE implementation.
Yes, sir.
This is command. Let's go with the router C. So here we have yes. So what you can do, you can okay. I'm using 0/1 interface. Let's focus on command syntax. This is the option to create MGRE. First, you can define
Okay.
your tunnel. First, you can define your tunnel number. Then you can define your tunnel IP, tunnel source. Then GRE, MGRE, GRE multi-point, IP and HRP network ID. So once you create your tunnel, how you can verify your tunnel is working or not properly. Okay, so you can verify your connectivity from this site A. You can verify your connectivity with 80.2, with 80.2 and with 80.3. If you have a reachability, then you have a MGRE tunnel, Akbar.
Okay.
If you don't have reachability, then it means there is some issue in your MGRE tunnel configuration.
What direction?
Clear now?
Yes, sir. Yes, I
Our
got it.
topic GRE and MGRE. Okay. Let's complete this lab tomorrow. Okay, Akbar?
Okay, sir. Complete that with
Tomorrow,
IPsec, right?
tomorrow same time. Can we connect at 8 a.m.? Is it possible? Are you available? Because tomorrow one of my batch is not available. 7:30 to 9 p.m. batches, 9 a.m. batch is not available. So are you
Only
available?
for tomorrow?
My time?
Only for tomorrow?
Yes, only for tomorrow. Yes.
It means I have to 5:30. Okay, sir.
5:30.
It will be
Okay, no problem. Let's
5:30.
let's connect 9 a.m. No problem. No problem. Okay.
Okay, sir. Okay, thank you. Thank you.
So
Thank you.
too early for you, right?
Okay, sir. Okay, sir.
9 p.m. Let's connect on time. Best time.
Okay,
Bye,
okay,
Akbar.
okay,
Take
sir.
care.
Okay.
Bye.